Hey guys, Steven from LOJ Conversions here today to give a little bit of tech information about this 300ZX that we've been working on here in the shop. Um, this is a 1990 Nissan 300ZX with a single turbo LS conversion in it. So this is a Gen 4 6-liter iron block LS swap with a TCI 6X transmission, which is actually a 6-speed automatic that's built out of a 4L80. It's got a TCI standalone controller on it to make all that work, and TCI basically customized the gear ratios and can engage overdrive in every gear, so you get first over, second over, third over, to get all 6 gears out of it. This car is also running a Holley Dominator standalone, and as you can see under the hood, it's a pretty elaborate setup with a lot of plumbing changes and all, because this is a complete swap with a single turbo, but also keeping air conditioning, keeping all the creature comforts in the car. So there's a lot of changes here. A factory 300ZX would have had a mechanical cooling fan. If it was a turbo, it would have had twin turbos and air coolers, obviously, but if it was a non-turbo, it wouldn't have. And because of all of the changes in this car, we've added a lot of electrical load on this car that otherwise wouldn't have been there in a factory configuration. Factory, you've got a mechanical cooling fan for the rad, and that's about it. There was an electric supplemental cooling fan for the AC, but that was it. But with this car, we've got a slant mount radiator in the front with dual electric fans, and then we also have a pair of heat exchangers. They're sandwiched together here that have a fan on them. These actually are plumbed in series and work as the water to air heat exchanger for the intercooler setup. On the other side of the car, there's a pair of identical heat exchangers, but one of them is for transmission fluid and the other is for engine oil. They also have a fan on them. Because this is a water to air setup, there's an electric water pump under this coolant reservoir that pumps the water through the intercooler system. So all of those changes have added a lot of electrical load on this car. And because of the amount of things that are kind of getting crammed into this engine bay to make all this work, trying to modify the factory engine bay wiring harness and fuse box to power all of that stuff would have presented more of a challenge than just starting fresh. So what we did was essentially remove the engine bay wiring harness, the factory harness, out of this car completely. On Nissan vehicles, and honestly probably a lot of other vehicles, but obviously for this particular car, the engine bay wiring harness kind of came through the inner fender, across under the radiator support, and through the other inner fender, and went through the firewall on each side, and there was a series of plugs that tied the engine bay harness into the car. Some things from the car went out to sensors in the engine bay, some things from the engine bay supplied power to the car, but what we did is we cut all of those connectors off of the factory harness, went through the factory wiring diagrams and identified what function all of those pins were for those 100 and something wires that had all those connections, and then started building our own harness. And a lot of people would have, at that point, just went to relocate the factory fuse and relay center into the car. We elected not to on this build. We wanted to simplify things, and in doing so, we purchased an ECUMaster PMU-16, which is a power management unit. It's an intelligent fuse box relay center. It's all solid state, so there are actually no fuses and no relays. It's all solid state electronics, and the reason we selected the ECUMaster PMU as opposed to maybe a PMU from AIM or any of the other suppliers out there is essentially because the ECUMaster was a 16-channel PMU that also allowed to have 16 discrete analog inputs for triggering each of those outputs. So it has 6 25 amp circuits and 10 15 amp circuits. And we were able to basically split up all those circuits to power electric fans, power all those cooling fans, intercooler pump. We actually used those circuits for powering the headlights, the high beams, the low beams, the fog lamps. We're using those circuits for controlling the AC compressor clutch. So a lot of ways to make that work was essentially, we looked at how the factory Nissan wiring, for instance, would have triggered the headlights. And it's actually incredibly complicated in these cars. There was a series of relays for basically analog circuits that determined when the high beams go on, make the low beams turn off. Each headlight left and right had its own relay. Fog lamps had their own relay, all of those things. Fog lamps would turn off when the high beams went on. The beautiful thing about the PMU is that we were able to wire all of those analog ground switch triggers from the factory wiring to the inputs on the PMU to command the PMU to turn those circuits on. And because the PMU is an intelligent computer-based piece of hardware, we can program logic in. So now when the high beam switch commands the high beams, the PMU just knows to turn off the low beams and the fog lights because of DOT regulations. When high beams are on, those are the only forward-facing lights that can be on. So instead of using a series of relays to make that happen, the programming in the PMU makes that happen. For air conditioning, we've got a modified vintage air setup on this car, and it's got its own triple pressure switch. But what we've done is we were able to take the ground switch AC request trigger from the factory automatic climate control, feed that to the Dominator. Then when the Dominator sees an AC request, it looks at all the engine parameters to say RPMs within range, coolant temps within range, anything you want to program at all with the Dominator. It's very flexible in that regard. When it says everything's cool, we can turn on AC, it then sends out a request to the triple pressure switch on the AC system. And then as long as the AC pressure is within range, it sends a signal to the PMU to request that the AC clutch turn on, and the PMU turns the AC clutch on. So we have all of the factory fail-safe type capability as far as throttle position, RPM, engine overheat, things like that to kill the AC will all work through programming within the Dominator. And that's one of the, like I said, that's one of the reasons we chose a PMU instead of a complex set of relays, because to do that kind of logic with relays, we would have had a mass of relays under the dash on this car to make all those type of things work. But instead we have one box that's literally about this big, mounted right under the dash cleanly to handle all of those complex tasks. We're also using the PMU to command the fuel pump. So we're bypassing all of the factory fuel pump wiring in this car. This car has a factory single 525 liter per hour Walbro pump. We're targeting about 700 horsepower in this build, so that'll be sufficient for that. But now the PMU is commanding the fuel pump as well, with a signal out from the Dominator. Now, again, I had said we chose the PMU because of that host of analog inputs. A lot of aftermarket other brand PMUs don't have that many analog inputs. They might be 16 channel, 20 channel, 30 channel, but they might only have 4 analog inputs, and the rest of the channels are designed to be controlled by CAN bus signals, which the Dominator can output CAN signals to make all those things happen. But because we're using so many of the factory controls in this car still to trigger things, we needed a PMU that had that many analog inputs capable of doing all of these tasks. I hope you can appreciate some of the tech that is in this video and some of the reasons why we chose the setup that we did on this particular build. This one is getting very close to completion, and I'm very excited about that. And I know the client will be happy with the amount of functionality that we were able to retain in this car and keep working. One other thing that I forgot to mention about the PMU as well, because it is a solid state device and not analog, you can actually program soft start technology in. And what I mean by soft start is you might have an analog trigger that says, hey, turn on the fans, but you can program the PMU to actually ramp in the duty cycle with the fans so that you don't hit your electrical system with a sudden surge of electrical demand. It brings the fans on slowly. You can program how long you want it to come in. And one of the other things that we can do that we still have left to wire, it's one of the last things left to wire, is you can wire discrete sensors straight to the PMU. So we can take an off-the-shelf coolant temperature sensor or oil temperature sensor, which is what we're going to do, put the oil temperature sensor in the oil pan, and then when the PMU has a 5-volt analog output and ground, 4 sensors, and then you can program the PMU for that voltage curve for that particular sensor, and we can basically have the PMU monitor engine oil directly and then command on the engine cooling fan based on engine oil temperatures. So there's a tremendous amount of flexibility with these units. This is honestly the first one we've installed. I've been wanting to do one for years, and this was the perfect candidate for it. I am confident after the positive experience we've had with this one that we'll be using many more in the future for other builds. It is honestly the smartest way to wire one of these cars, especially keeping factory functionality. And then in full-blown race cars, they're wonderful because you can mount a CAN keyboard in the chassis, which is essentially a programmable set of keys with 2 wires connected to the PMU, well, 4 wires, power, ground, CAN high, CAN low. And you can program any one of those buttons over a CAN network to command any function, in the PMU for headlights, turn signals, and all that if you want to gut all of the factory wiring out of the car and just simplify your race car chassis wiring. Thanks so much for tuning in for this video. I hope you learned some out of it, and please like, subscribe, follow us here. Honestly, the best place to follow all the latest updates for LOJ Conversions is on our Instagram feed, but we're also active on Facebook and here on YouTube. So thank you so much for tuning in, and God bless.